Identifying vertical asymptotes of rational functions. By looking at the graph of a rational function, we can investigate its local behavior and easily see whether there are asymptotes. We may even be able to approximate their location. Even without the graph, however, we can still determine whether a given rational function has any asymptotes and calculate their location. Vertical asymptotes. The vertical asymptotes of a rational function may be found by examining the factors of the denominator that are not common to the factors in the numerator. Vertical asymptotes occur at the zeros of such factors. Given a rational function, we want to be able to identify any vertical asymptotes of its graph. Number one, we need to factor the numerator and denominator. 2, note any restrictions in the domain of the function. Number 3, reduce the expression by canceling common factors in the numerator and the denominator. Number 4, note any values that cause the denominator to be 0 in this simplified version. These are where the vertical asymptotes occur. Number 5, note any restrictions in a domain where asymptotes do not occur. These are removable discontinuities or holes. Now for example 5, we want to identify vertical asymptotes. We want to find the vertical asymptotes of the graph k of x, which is equal to 5 plus 2x squared over 2 minus x squared. So the first thing we want to do is we want to be able to first factor the numerator and denominator. If we look at the numerator, okay, it's already in simplified form. There aren't any common factors between those two terms, 5 and 2x squared, so we cannot factor anything out there. Now in the denominator we have 2 minus x squared. I'm going to rewrite this now as negative x squared minus x plus 2. So all I did was write the minus x squared at the beginning and a 2 at the end. Now since the leading coefficient is not a 1, we're going to have to use the AC method to factor. Well, A is negative 1, C is positive 2, so we multiply them together, we get negative 2. So we have negative 2 up here, and then the middle number is negative 1. So what two numbers can you multiply to get negative 2, and what two numbers can you add to get negative 1? We get 1 and then negative 2. Now if we go further, now we can rewrite the first term as negative x squared. These are the two middle terms, plus 1x minus 2x, and then plus 2 meaning the last term. So now I'm drawing a line here to then factor by grouping. So what can I factor out of the first two terms? I can factor out a negative x, and what's left is x minus 1. That means I should also have x minus 1 on the right-hand side here. So when I look back up here and say, what can I factor out so I'm left with x minus 1? Well, we have negative 2. Now, we can then write this as x minus 1 times negative x minus 2. So now we factor the denominator, so we got 5 plus 2x squared over x minus 1 times negative x minus 2. Now in step 2, to find the vertical asymptotes, we determine where this function will be undefined by setting the denominator equal to 0. So we're going to set the denominator equal to 0 now that we factored. So we have x minus 1 times negative x minus 2 is equal to 0. We set x minus 1 equals 0, add 1 to both sides, x is equal to 1. Over here, we're going to add 2 to both sides and divide by negative, which is going to give us x, which is equal to negative 2. So neither x equals negative 2 nor x equals 1 are zeros of the numerator. So the two values indicate two vertical asymptotes. So the graph in figure 9 confirms the location of the two vertical asymptotes. So here is our asymptote at x equals negative 2, and then our other vertical asymptote at x equals 1. And that's all we're looking for right now are the vertical asymptotes. Now this graph does have a horizontal asymptote, but we'll look at that in a different example. But again, here's how we found the vertical asymptotes by factoring the denominator, setting it equal to 0, and finding out what those values are for x.